good morning, everyone, and welcome to our Real Estate AI in Action Masterclass. I'm very happy to have you all here, and I'm Monica Dino. I'm a VP Growth and Marketing at Alasco, and I will be your host today. Before we start, a little bit of housekeeping is being recorded, and afterwards you will receive the recording together with the presentations that you're experiencing in a few minutes. Feel free in the meantime to use the Q&A to address questions whenever they pop up, and we'll do our best to answer them either during the conversation or we've saved some time towards the end. Let's get going. This is first about the session. This is our third chapter in this masterclass. This is for you if you are an asset or property manager, if you're an investment manager, or if you're a developer. If you're hearing about AI everywhere, but you want to understand its strategic value for your business, again, this is for you. If you're looking for concrete use cases and case studies that actually work in practice, again, this is for you. And what you're also going to experience today is a few pieces of research around AI in building operations, which definitely will impact how we manage our buildings in the future. So, welcome again. The full series right now, just a quick recap. The first two sessions are on our page on YouTube. I will send these over together with today's presentation. Today we have the real estate in action, use cases and case studies in operations. And then we have scheduled 3 more sessions. Again, one tackling operations, the other one tackling construction and development. And the last one, which I'm really excited about, is how do you do change management when deploying AI within the organization. So please stay tuned and do register. As I said, I'm your host today, and it's my pleasure to introduce you to Sylvain Helin. He is a researcher at TUM and director at Lenbermeyer Center, a research center within TUM, and he's also a director at Heinz. So a very interesting perspective, both a researcher and a practitioner. Then we have Cătălin Drăguțoiu. He's head of growth at Brightspaces, a very exciting startup that deals with digital experiences and helping property and asset and investment managers improve their leasing operations and tenant relationships, of course, with the help of AI. And then last but not least, we have Matthias Munk. He's head of sales at aedifion. Another super interesting and fast-growing startup which is dealing with building data and predictive maintenance and using AI to better manage our buildings. So that's the team. Finally, before we start, a quick word on Alasco. We're a company based in Munich, and we deal with financial management for new developments and retrofits. We work with a few very famous customers, but you can see them on the screen, but also small and medium developers across the whole of Europe. So just so you know where you can place us. Okay, with that, let's get started. And I would start with a question for the interns. AI has been quite successfully deployed on a construction side, so how we build buildings, but from our experience, not so much on existing buildings. With that being said, most of the value of a building across its life cycle comes from the actual operations and also most of the costs. So here's the question to you. How do you see this evolving with AI included? And what can we do to speed it up? Please, whoever wants to pick it up. Sylvain, maybe you start.
I am very sorry, Monica, but I was also reorganizing my screen, so I haven't listened to the question perfectly, if you don't mind repeating it.
Yeah, I was saying, due to our previous conversation and everything, that AI is really being deployed on the job site in construction. Pretty solid use cases there. But in building operations, it seems the uptake, the adoption, slower.
Yes, I remember we spoke about this.
How do you see that?
I don't even agree with the premise. I'm not sure it is actually true that it's more being deployed more on the construction side than it is on operation. You have a lot of prototype, you have a lot of a startup being created, a lot of research project also targeting the construction side and also the planning side and project management side. So we have a couple of verticals that are being targeted. But I haven't seen something that is really became mainstream of using AI on the site right now. And I don't have any numbers to back this up, but it will be interesting to test if we don't even have more use case in operation with this like predictive maintenance scale and energy optimization on the BMS level and everything for the buildings that are also equipped with the right software like aedifion and have a couple of sensors to make this possible. But it takes a bit less, let's say, hardware and software layer on top to get real value immediately by, for example, lowering energy consumption. Whereas in the construction construction side, so it's quite hard to get something working on a very diverse and always evolving environment. So I don't know what my colleagues think about this topic.
Yeah, well, I kind of agree with you. Obviously, like when you look at planning and construction, you're always starting from scratch and you're always creating something new. So it's easy to think about where do I have all the data and how can I use the data? But it's a bit more complex when you have an existing building and the data is stored in paper folders somewhere in the basement. So that's why I understand where the thesis comes from. So when you use modern, I don't know if it's a CAD system or if you're planning in BIM or whatever, you have way more data than if you operate a building out of the 60s. And the AI lives from data. So if you don't have enough data, it's hard to use AI. So that's why I would assume that it's easier in construction than in the building operation. But that's why we're here.
Yeah, that's a very valid point. Thank you.
Speaking of AI and operations, one of the main goal of operating a building is to always have a constant cash flow. So whenever you have a tenant leaving, you can pre-visualize that space using our AI tool to help showcase multiple ways that space can accommodate different needs. So you can actually pre-fill the, let's say, the void before the actual tenant moves out. So that's something that can be useful on the way AI impacts pre-visualization.
Yeah, and we're looking forward to seeing what you have for us today. With that being said, Sylvain, I'm gonna pass over to you.
Thank you. Yes.
Share the screen.
So let's start. Right. So thank you again, Monica, for having me today and for the introduction. Today we're going to talk briefly about a couple of research projects that we do at the Leonard Obermeyer Center, which is TUM Center of Digital Methods for the Built Environment. And in a nutshell, it's a group, let's say a research group, gathering together 6 research labs from TUM that have anything to do with, let's say, computer and the built environment, like architecture, informatics, combining in civil and building engineering, and so forth. With a couple of industry partners, most of them are software developers like the MHA Group, Hexagon, Bentley, or heavy software user like the CATFEM group, Obermeier, or Listgruppe. And at the moment, we have more than 80 researchers working on different topics, all more or less related to this broad range of digital methods. And if you want to pick a couple of these topics, we have numerical simulation, point cloud processing, artificial intelligence, topic of today, BIM, digital twins, smart cities, and so on. So if you're interested in any of this stuff, feel free to reach out later on. Now, before I jump and present two projects that we have at the moment, or one of them is being finished, I just want to give a really quick background about what is maybe BIM and digital twins. So a building information model, or a BIM, is just a digital representation of a physical asset. And if we add on top some real-time data, like sensor data of temperature, humidity, whatever, from the inside of a building, and store this information in real time, then we can consider this to be a digital twin. There are many definitions, but that's the one we are going to use for today. So digital representation with real-time data. And it has a lot of advantage if you have something like this for your operation. You can consider this a single source of truth. So as Matthias said before, you don't have to hopefully go and look into the basement for up-to-date drawing or your maintenance schedule and all of this stuff. You have everything into one platform. A lot of workflow can be automated. You can perform some simulation, have a lot of reporting of energy consumption, LCA, and so forth. But it's if it's that good and not yet mainstream, there is a cool reason. The first one is the model update. So if we really want to be able to consider these digital twins to be the single source of truth, it needs to be up to date with the physical reality. And the thing is that buildings are not static; they are constantly evolving. We're constantly doing some stuff, some retrofits, some refurbishment, moving some part, changing some technical aspect. And each time we do something to the building, if we want the digital twin to really represent it, we need to update the digital twin. And right now, this workflow is very time-consuming and quite expensive. You need to send a surveyor on site, take a point cloud to a survey, create a BIM model out of it, and deliver it and relink everything to your other software. It costs a lot of money, it takes a lot of time, so it's not really something you can do every time a tiny thing changes on the building. And the other difficulty that you have is that once all of this information is modeled into a digital twin, it's not always easy to access, because you cannot just take a drawing and have a look at it and understand it. You are relying, let's say, on the user interface, on the software interface, software layer that interact with this digital twin. And some people like aedifion do a good job of presenting maybe this information clearly, but not all softwares are quite easy to target, especially if you are just using it from time to time and want to get a quick information out of it. So what can we do about these two pain points? So for the first one, a colleague of mine has developed a method for automating the process of generating as-built models. It starts with a point cloud, so it's the same workflow, let's say, or same starting point as the current workflow of sending a surveyor on site and then creating the BIM model, but then it's automating the process of creating the BIM model. So this is the overview. It looks a little bit complex, but it's divided into three main segments. The first one is a semantic segmentation of the point cloud. We'll see what it's mean in a minute. Then we create the base geometry, and then we add more elements, so richer information inside the model. What does this mean? So we start with this point cloud. I hope you can see it's clear enough on the pictures. What we see here, our point cloud, and it's basically just a huge collection of points. So you have the coordinate X, Y, Z, and the color of it. And you can really move into it like a 3D space. And we have a couple of AI methods now which are able to identify for each of these points to which element does it belong. We can see a little bit beneath the three pictures that we have on the second row, the colors, different colors, green for the walls, for example. We have the windows in yellow. So this is the first segmentation. Here it's about the space, so identifying which point is in which space, in which room, and it's when it's targeted specifically at the walls. So we have a couple of these AI algorithms running and trying to put a label on all of these points that we have. And with this information, we can train another optimization algorithm. We'll try to fit actually this parametric model, so this base geometry, to best fit what we have, this representation, this measurement we took from the building. And so at the end of the day, you get this. So it's a geometry called the base geometry, which fits perfectly with the point cloud that we have. And this is something that we can use as with a computer as a baseline for a BIM model. But right now it's a bit boring. We only have slabs and walls, so it's not super useful, let's say, for operation. It's more just a shoebox. So what we want is to add richer information. We want to add some elements that we have in the building. And on the research project, he was focusing on windows and doors, but the method can be applied to also the lighting, fixing, radiators, every element that you may have. You need to tweak a little bit the pipeline, but it's very scalable also and generalizable. And we still work with the same single input data that we had before, so this point cloud. And what we do, we make some cut out of it to create 2D images. And then we have other AI algorithms, some object detection, and some other semantic segmentations that try to find where are, in this case, the windows and the doors and their dimension and their shape. And then we have the last AI algorithm trying to do this matchmaking with a catalog of objects that we have. So if you know that you have 5 different types of door, 10 different types of windows in your building, you only have to create these components one single time at the very beginning. And then this algorithm is able to find in this catalog, the window which corresponds to the image and add it at the right place on the model. So in the end, you get a very detailed BIM model that where no human had to do any intervention, let's say, to create this. You need the point cloud at the beginning, but then all of the modeling process happens automatically. And so in the future, when we circle back to the workflow we saw before, every time we have a change, you have also a lot of companies developing this mobile laser scanner. So you can buy one of these and send an intern or facility manager or someone on site to just take an updated point cloud of your facility, put it into the algorithm, and then get an up-to-date BIM model. So this way you will always have a digital twin that match the physical reality on site without having to go through this very costly and lengthy process. Just one time invest to buy this machine, and then every time something changes, you make a small walk into it. So in reality, it's not there yet. So the research project works. These machines exist, but the full end-to-end pipeline, we have a couple of startups targeting it. It works decently, but it's not yet a perfectly seamless experience. But I believe it will be in a couple of years now with more optimization. So with this, we have, let's say, take care of the first pain point of keeping up-to-date digital representation of the physical reality. Now what we want to do is try to improve the accessibility of this information for normal users. And the problem that we have is that this information is usually not very easily accessible. So if you, for example, get a ticket as a facility manager with the name of the office and you want to retrieve the information regarding, let's say, the radiator or something like this, it's not a straightforward process to find this with the user interface that you have on this software. It's a very complex data structure. You need to understand also how it's modeled under the hood. And it's really targeted at the power user, not at someone that will open this software every 2 or 3 days just to pick one information. And what we would like to have is something a little bit more than what we have for web search. We have very powerful and easy to use AI-powered search engine like a Perplexity, where it's possible for us to just ask a question in natural language, in English or in German, or any other language, and let the AI look for, through all of the internet, what is it that we are actually looking for. And so what I have done is try to build this for the build environment for the buildings. So this is just a quick demo of a prototype where we first select the BIM models we are interested in, then load it, have a tiny small viewer that we can visualize it. And then right now, quite mainstream nowadays, chat interface, you can think of it as ChatGPT. But instead of just having access to the web or to a calculator or these kind of tools, it is able to look for the information inside the BIM model. So here the question is, can you give me the list of all the door type we have and their respective quantity and dimension? And the AI look into the BIM model, into this database, and retrieve all of this information, give me this detailed list, and also explain where it was found if I want to double check with another more powerful software by myself if I don't trust it. And under the hood, it's actually not a very complicated process. It's just a single AI agent. An AI agent, a very simple definition, is just an LLM equipped with tools that runs in a loop until it achieves a goal. That's it. So when your question is being sent to the model, to the LLM, it's not just directly sending the answer, it's starting a loop like this, going to run in a circle for a couple of times. So the LLM first, when it got the question, decide to take an action. In this case, the action is the ability to communicate with the B models. We have special tools for this. Get the result of it, and based on this observation, can decide to take another action, and it can go for a while until it gets all of the information it needs to answer the question. And then when the LLM thinks it's done, then the answer is being returned to the user. So to put this also a little bit more perspective on the question we had before. So this is the tracing, so the logging of the question we had before. So for us, we saw like this spinning wheel for a while until we saw the answer. Under the hood, we actually had 4 back and forth, these 4 iterations. So 4 times we were sending a request to the LLM, asking for stuff and giving it more information. And the first 3 times, the LLM is actually replying with its code action. So it's writing code using the tools that we put at its disposal to find the information it's looking for in the B model. And we execute the code locally and send back this information to the LLM. And with this information, can decide what you want to do. And then after the 3rd iteration, it found everything it wanted. And then it's not sending some code to execute; it's sending the final answer. And you can see it's the exact same answer that we saw before. And I'm not sure if you could see it, but on the 2nd iteration, it actually made an error. So the code that was written by the LLM was wrong. And so it got this also as a feedback message. Say, hey, it doesn't work what you wrote. And here is a line that doesn't work. And that's the reason why it doesn't work. And so with this information, the LLM is also able to correct this. And so we say, okay, true, I made a mistake. I'm rewriting the code. That's what it did for the 3rd iteration. This time it was correct, was executed successfully. And the LLM got access to the information it needed to answer. So that's a little bit how most of these chatbots work if they help you interact with the software. And now I'm almost at the end of this presentation. It's just want to speculate a little bit with you about how the future of building knowledge management or facility management can look like in the future. So I think today we still have a lot of manual work to do. We have a lot of data silos. So each app needs to, we need to enter data into each individual app that you are using for the different purpose. And we have limited automation within this app and especially across different apps that we're using. I think in the near future, we will see also this app getting smarter, more or less all of them integrating like a chat or a voice assistant to help you use the software more efficiently and easily, and have some partial automation within this software. Midterm, what I think we will see also is more connected intelligence, so less silo and more connection between the different tools that does a different job. I'm not sure we will have one super app that does everything. This is we will see, but even if we stay with different apps being very good at doing one specific function that is needed to operate the building, we will be able maybe to extract the relevant information and to feed it back into another system and not having to do this double data entry between different systems and have some broader, smarter automation across these different systems. And while speculation in 5 to 10 years, maybe facility management looks like steering an army of AI agents doing all of this cron job. And facility managers can focus on making strategic decisions for the building, when to renovate it, what to do with it, and spending more time also engaging with tenants and improving the tenant experience and less about crunching data reports and this kind of stuff. And with this, I am done. I would like to thank you for your attention. I hope this was informative. And if you have any questions, I will do my best to answer them.
Thank you, Sylvain. I think it's really fascinating because, you know, it feels like we're really taking steps to take this BIM from the very start all the way through the business operation. It was a beautiful concept a couple of years ago, but now it kind of feels more and more real.
Yeah, BIM hasn't lived up to its promise of making all of this process easier so far. The hope and the thesis that we have here at TUM is that with the proper use of AI, we can reduce all of these very annoying jobs that we have to do to get a proper BIM model and get most of it automated so that we can get the benefits of BIM without having to invest a huge amount of time just getting this data model structured properly. We'll see how it turned out.
Indeed. Now, let's move on to you, Katalin, and to seeing a little bit how this AI actually looks in practice and in the leasing process. So that's a good segue. Over to you, Katalin.
Hello, everyone. Thank you, Monica and Alasco team for hosting this and having us. I hope whatever you'll see today in terms of office space planning powered by AI will make sense for the leasing process, because today we know that the biggest friction in leasing office is the imagination gap. So if you take a prospective tenant to a gray empty shell and hand them a 2D floor plan, the scope is that you hope that they will see that this is their future headquarters, but the reality is that the modern day tenant involves a lot of multiple decision maker, multiple stakeholders, and they have a misalignment when they are looking at the same thing. So looking right now, sharing the screen. Not so long ago, TestFit is a 2D black and white PDF, which is easily imaginable in different ways by multiple stakeholders. With our intelligent 3D space planning, you can bring the product to life. Product meaning the office space. And everything that I'm doing right now is done on my web browser, so you don't need any heavy tools. You're able to walk around through the space using the arrows or just the mouse. Or you can see, just a second, you can see different high resolution renders that you can download, or it can teleport you there. Go to, for example, in a meeting room and see it in a higher quality. And again, teleport yourself. These renders are obtained with an AI model from the backend part. In order not to hallucinate, we had a workflow of multiple AIs that help us achieve a higher quality of the visual output while maintaining the accuracy of the elements used inside the test fit. Another AI enhancement that we have in all of our space plans is the AI virtual tour. So from the admin panel of the space, you can create as many tours as you want, and you can automatically enhance them to this quality, so everybody can see as best as possible the visual representation of their future office. So suddenly you're not just selling an empty shell or a black and white populated space. You're presenting how the office can look like or how the team can function in the space. You also have some teleport points that can bring you to different areas of the space and continue the AI video tour from that space. You can exit the tour, go back to the 3D model, see it from a 2D perspective with a space summary. But what I want to show you right now is something that is a world premiere, I can say. I'm gonna start Archie here, who is your very own leasing and space planning assistant. At this stage, you're with our technology, you won't be sending any more test fits. You would be actually sending a live floor plan with all the information that you need in order to understand the space. Now, I'm able to ask Archie about everything here. If I want to go, for example, I'm in a open workstation. I can ask him, just a second, to tell me about this area. And right now, what you saw that Sylvain was showing you, it's an AI agent that uses an LLM and goes through a loop, understands everything that it sees here in the space plan, and it's providing you with that information. So you can tell him to act as a leasing agent to actually reissue the unique selling proposition that you have for the space. For example, I can also tell him to replace the chairs. So if I click the button, right now it will identify the chairs that the agent sees, and it will give me a few options to change. I can also tell him to change only one chair if I like. So I want to change only the left chair. That's exactly what's going to happen. This is basically a space plan that helps you understand. The task already has been executed, apparently. Probably Archie being the first time that is being viewed by the world, it's a bit shy. But the point is that this is the first time you will have conversational space planning in first person. And the thing that we are building on top of this is, besides the actual furniture replacement using the AI agents, also the recreation of rooms entirely will be available with this, and connecting them with all the information that you actually need in order to build out the space, like bill of quantity. So whenever you are making a change, everything gets updated in the backend, so you have live information about what's designed for that space and how it's going to look. So I'm looking forward to having questions on top of this, and looking forward to seeing it more and more used.
Thank you, Katalin. Actually, we do have a question. So, actually, two. If the visual elements, so I imagine like desks and chairs and setup and partitioning walls are clickable, so can you interact with them in any way?
Yes, you can interact either via the agent. You can tell him change the Vita chairs or the steel cage chairs, or in the backend, in the admin panel, you have the possibility of interacting with every element, even the floor, even the let's say the walls. Everything is clickable and changeable, amendable, while keeping the safety rules in place.
Great. So I hope that answers the questions. And the next one is, how about your main customers? Who do you typically sell to? What's kind of the business model between the asset manager or the owner and the tenant, prospective tenants?
Let's say our customer profile, ideal customer profile, is the office landlord or developer with vacant office buildings. It can be off plan, it can be existing, it can have already a tenant in place that is moving out, and everything can be generated in order to match future tenants' demands. So basically, in any office leasing process, you get a brief of how the tenant wants. Besides the surface, I need to fit in 100 people here, so you need to show him a test fit and how the team will operate there. So this is our main target, but we also work with asset managers that basically run the buildings for private large institutions that invest in office properties.
Thank you, Katalin. Well, I think it's time now to go a little bit under the hood, because we've seen kind of the space with the fancy chairs and the office plans, but what's really running this building and the experience for the tenants? So maybe over to you, Matthias. I know aedifion has done some great advancements and projects in this space.
Yeah, thank you very much, Monica, and also the both before me, because basically that was a very, very well structured introduction to what we're doing right now. We have the background about data models, digital twins. We've seen how that can enable visualization in a 3D kind of term. We always go to the not so shiny places. So somewhere down in the basement where all the technical building equipment is located, and I'm gonna take you on a small tour on how that actually looks and what we do over there. So very brief, in a couple of sentences. So we connect with our platform, we connect to the existing technical building equipment. we pull the data into our cloud. We make use of the data in order to spot inefficiencies within the operation. For example, the heating is running 24/7 in an office building that is only used 10 hours a day, 5 days a week. And we then go through these findings with the operator in order to solve them. And then we can make use of AI controls to further steer or control the building that it is very so to get it to the highest efficiency grade. So that having said, how does that look? It all starts obviously with an overview of the portfolio that we're connected to with our customer. But let me dig into one of the buildings and let me dig into basically the source of all of it. Sylvain explained it. There's a lot of data, and basically we could, let me quickly just take a few examples. So we get live data from the building, and this is basically the data from 1 week ago until today for a boiler input and output temperature. We also have the weather temperature here. So we get live data from the building. It's a long list of data points. As you see here, it's 37 pages. Not everything is explained in a way that you could understand it. So what do we do with that? We built small digital twins, so a representation of the heating circuit, for example. And so so we have basically all the technical equipment in the building we can find here as a digital twin. And in this case, we have 10 heating circuits, and we are running 25 analyzers on these heating circuits. So let me dig into one of them. How can that look? So for example, here in heating circuit 1, it says there's a red, so we have red, yellow, and green, obviously. Clear what that means. So there's the temperature spread is too small. So when we look at that, he gives us some more information. And we do see all the data points that combined represent the heating circuit 1, so the digital twin of the heating circuit 1. These are the data points. We have matched them through a partially automated, but unfortunately not yet fully automated process of mapping them together, because as you've seen, the naming of the data points not always allows us to fully automate it, but we're also working on that. So we have combined them into a digital twin. We get some recommendations on how we can solve that. And this is what we go through with human AI, so the operator in the building, and we explain him what to do. Having said that, some of them are really ambitious. They want to do it themselves, so they get some information here. But they can also ask, how can I solve the temperature spread? And yeah, as Katalin already showed, you can basically start interacting with the data, and unless you have the data, it is impossible to use the power of AI in order to become more efficient. And since there is a large shortage of skilled workforce, especially in the operation kind of sector, it's really helpful which data points can be adjusted to solve it. So I can literally as I ask ChatGPT or Gemini or whatever about everything in the internet, I can now use the same technology to ask questions about my build. It gives me the exact data points that I need to adjust in order to solve that kind of issue. And I think that is one of the main powers of AI and of large language models that we can make use of in order to become more efficient, to become more efficient as organizations, but also to operate the buildings in the most efficient way. So that is one component of AI in our platform. Then there's another whole section about the topic, and this is our controls algorithms. So we call them apps. We do have to make it visible and to make it understandable towards the operator and the asset manager. We have cut our AI control of the building into small little pieces, and they are all kind of pretty well explained. What do they do? And just to go into one example, what do they actually do? So the so-called frog, it's a free cooling algorithm that steers the air handling unit. So we do see that it takes a lot of input, but it takes input factors and analyzes how can I, so based upon the usage of the building, how can I make use of all these data points? And in this case, it switches the main command on true and sets the supply air temperature to 22%. To 22 degrees, sorry. Yeah, so all of these apps, so they can run on different components. They have different focuses in order to get the maximum efficiency out of the building. So this is all about operating a building right. It is about operating a building in a very efficient manner. So now you could discuss, does efficiency necessarily mean less energy? It depends. Just to give you one more example, what we also do is that we analyze the energy price, which you see here in the green line, and in blue you see the normal energy consumption, and in orange you can see the consumption after we have adjusted it. So what do we do here? As you can see, the energy price goes up, yeah, and some customers they actually buy energy at the spot market, so they would pay a really high price here. So you see the blue, the actual, so the standard consumption would be here, and since we're able to adjust it in the high-priced times, they pay less for their energy, and therefore in this part where the energy cost is low, we just increase the consumption. So we can actively make use of the volatility of energy prices and shift operating hours into cheaper sections of the day. And since we normally also get feedback in terms of from sensors from the space, we can make sure that it has no impact on the air quality or temperature on the actual floor space. And so again, here for this building, a saving potential of 18% just by shifting operating hours. So again, very clear example. Every morning at 8, every office building is getting heated up in the winter because at 9 the workforce comes in. So energy is relatively expensive between 8 and 9. So why not use the time between 7 and 8 to heat up the building, and then just go down with the energy consumption between 8 and 9 where it's really expensive. So that is what we do. And these are a couple of components that inherit AI in our platform. So I hope that gives an understanding. And there are many more components where we work with AI, but those are like the three most tangible results of it.
Yeah, and I'm gonna say this is fascinating, and I think it's the third or the fourth time you've heard me say this, but it's really exciting, especially as we see overall in real estate a drive towards this operational real estate where people are not hands off anymore, but really try to optimize the NOI in the building. Matthias, I want to come back to a topic that you mentioned earlier around buildings in the 60s. So I can imagine a deployment of your system on a new building. It's, I wouldn't say quite straightforward, but you have the new BMS systems and everything is kind of connected. How much or to what extent it's possible to do this on an older building, and what would that involve?
So for an older building, it is a bit more challenging than for a modern new building. So when we look at an old building that does not have a BMS system, that does not have a building automation system, so there's an old 60s heating boiler in the basement and maybe an air handling unit on the roof. They don't talk to each other. Obviously, that makes it a bit more complicated, but there are ways so first of all, to do the analytics, you just need some sensor data, input temperature, output temperature, operating mode of the air handling unit. So that is relatively easy with very little investment. You can retrofit some sensors. But then it's also possible if you have pumps in your heating cycle to retrofit basically the pump. There's one part that can be exchanged. So most of the companies that produce these pumps have updated their hardware as well. So it's a small retrofit to make this pump controllable, and by controlling the pump you can control the boiler. So there are ways to get there, and that is also our belief that it should be able to steer every building. Of course, there is always the edge case where it doesn't work or it doesn't make sense, or yes, that happens, but our approach is to optimize every building.
Okay, good to know there are hopes also for the older stocks of buildings. Okay, we're nearing the end now. I want to thank our esteemed guests today. I hope this was fascinating for you all as it was for us. And we'll circulate the recording and obviously your contacts. So feel free if you want more information from Matthias, Katalin, or Sylvain. I suppose people can write to you and connect with you directly.
Of course.
Of course, yes.
We are looking forward to.
Same here. And let's go and build something wonderful with AI. Thank you all.
Like a good plan. Thank you for organizing this. Bye-bye.
Thank you,
Bye-bye.
Monica.